Section: Introduction. In this section, we discuss how large language models, LLMs, have been beneficial in understanding complex instructions and have been widely used in various tasks. The Information Retrieval (IR) community has embraced LLMs in their neural retrieval systems, leading to significant advancements in semantic search. However, current systems still rely on basic keywords and short sentences, despite the potential of LLMs. Even though larger IR models like Llama 7B are being used more, they are mainly employed to estimate document relevance without specific instructions. Transitioning from this basic search approach to a more advanced one with instructions could empower experts to pinpoint complex information needs using natural language, adapting to different tasks seamlessly. For instance, imagine a researcher looking for papers meeting specific criteria while also avoiding irrelevant ones based on various factors. While some recent work has started exploring search with instructions, it is still a relatively unexplored area with only a few studies available. To address this gap, we introduce FOLLOWIR, which includes a benchmark to assess how well retrieval models follow instructions. We provide diverse and realistic training data to enhance the instruction following ability of these models. Our approach is inspired by the detailed instructions provided to human annotators in TREC conferences, which highlight the nuances of document relevance. We utilize 3 extensively annotated TREC collections: TREC Robust 2004, TREC Common Core 2017, and TREC News 2021 to create our evaluation set. By slightly modifying the original instructions given to human annotators, we form paired instructions to evaluate how models adapt to different instructions. We introduce a new evaluation framework, PMRR, to measure changes in document rankings when presented with different instructions for the same query. Our findings from FOLLOWIR reveal that current models struggle to follow instructions in retrieval unless they are large or specifically trained for retrieval tasks. We identify 2 main reasons for these shortcomings. Models are not accustomed to lengthy instructions, and they often treat instructions as simple keywords rather than defining relevance. To enhance the understanding of instructions by retrieval models, we develop a training set based on real-world instructions and fine-tune a model, FOLLOWIR-7B, on this data. Our results demonstrate significant improvements in both traditional IR metrics and PMRR, indicating a promising direction for future research on instruction following in retrieval tasks. In summary, our contributions include a benchmark, FOLLOWIR, for evaluating instruction following in retrieval, an analysis of current model limitations in understanding instructions, and training data to enhance instruction following in retrieval models, along with a new open-source model, FOLLOWIR-7B, capable of handling complex instructions in IR tasks. Section Summary. In this section, we summarize the importance of incorporating instructions in information retrieval systems. Large language models have significantly improved semantic search capabilities, but current systems still rely on keywords and short sentences. To address this gap, we introduce FOLLOWIR, a benchmark that evaluates how well retrieval models follow complex instructions, highlighting the need for models to understand and adapt to detailed search criteria for more effective information retrieval. Section: Instructions for LLMs. In this section, we delve into the realm of instruction following language model, LLM, research, which has gained popularity with models like GPT-3. Evaluating the ability of LLMs to follow instructions, generalizing to new instructions, training without human annotated data, and applying them across different domains have been key areas of interest in the natural language processing community. As the Information Retrieval (IR) community incorporates LLMs into their models, we aim to expand the scope of IR to include instructions, aligning it with the broader NLP community. Exploring the use of instructions in retrieval is a relatively new area. Early works trained retrieval models to utilize short instructions like, retrieve a Wikipedia paragraph that answers this question. Recent efforts involve integrating instructions in smaller models and using Mistral as the foundation for larger retrieval models that can follow instructions. However, there is a lack of explicit benchmarks specifically designed for instruction-related retrieval evaluation. Current models often handcraft a few generic instructions applied uniformly across datasets, lacking real-world instruction complexities like background information or negation. In parallel work, a dataset has been proposed to evaluate instruction-based retrieval models using the MS-Marco collection. This dataset differs from ours in key aspects such as sparse relevance judgments, GPT-4 generated instructions, and evaluating model robustness by considering multiple instructions for the same query. In contrast, our approach focuses on highly judged corpora, human-generated instructions, validated relevance judgments, a novel evaluation protocol, and a dedicated dataset and model for instruction following. To construct our benchmark, FOLLOWIR, we leverage existing TREC collections. TREC News 2021, TREC Robust 2004, and TREC Common Core 2017, each annotated with instructions and relevance judgments. To assess models' instruction following ability, we task expert annotators with modifying TREC instructions to test models' responses to subtle instruction changes. By making instructions more specific or incorporating negation, we reduce the number of documents needing re-annotation, making the process manageable. We select a subset of queries from TREC Robust 2004 and TREC News 2021, modify instructions to have the relevant documents, and evaluate models based on their ability to adapt to these changes. Given variations in retriever performance, we adopt a re-ranking approach using a pool of models to select top non-relevant documents, ensuring fair evaluation despite differing retrieval outcomes. By chunking documents into passages and leveraging max-P scoring, we facilitate data distribution in compliance with fair use laws, extending the MTEB evaluation framework. Section Summary. In this section, we explore the use of instructions in retrieval models, focusing on training models to follow instructions alongside queries. We introduce FOLLOWIR, a benchmark dataset built from existing TREC collections with human-annotated instructions, aiming to evaluate models' ability to respond to changes in instructions without requiring extensive re-annotation of documents. By incorporating specific aspects and negation in the instructions, we aim to test and improve models' instruction following capabilities in retrieval tasks. Section: Evaluation Metrics for FOLLOWIR. In this section, we present the evaluation metrics we used for FOLLOWIR. We have two main ways to measure instruction following. Firstly, we employ standard retrieval metrics by incorporating the instructions with the queries. Secondly, we introduce a novel pairwise evaluation method to assess instruction following. For the standard retrieval metrics, we utilize mean average precision, MAP, for Core 17, Robust 04 and normalized discounted cumulative gain at 5, NDCG at 5, for News 21. On the other hand, our new pairwise evaluation metric, called PMRR, focuses on measuring the difference in scores when following modified instructions compared to the original ones. This metric considers the rank of documents, giving more weight to changes in higher ranks. To calculate the PMRR score for each relevant document per query, we use a specific equation involving the mean reciprocal rank, MRR, the rank of the document with the original instruction, R_odd, and the new rank, R_new. We then average these scores within each query and across all queries in the dataset to handle variations in the number of relevant documents per query. We proceed to evaluate various IR models on FOLLOWIR, including neural models with different parameter sizes. Some models were trained without instructions, such as Contriever, E5, MonoBERT, Minot5, and BM25. Others, like models from TART, Flan T5, E5 Mistral Instruct, Grit LM, and BGE, were trained with instructions that defined the domain, document size, and task format. Additionally, we assess API embedding models from Cohere and OpenAI, whose training procedures regarding instructions are unknown. We also evaluate instruction-tuned LLMs like FLON T5, Llama v2, and Mistral Instruct v0.2 as re-rankers. The results are presented in a table showcasing the standard IR scores and the PMRR metric. Our analysis reveals that models trained without instructions exhibit a range of standard IR metric scores but generally have negative PMRR scores. In contrast, models trained with instructions also tend to have negative PMRR scores, except for a few exceptions like TART-FLON T5XL and GRIT-LM. The API models perform well in standard IR metrics but struggle with instruction following, showing negative PMRR scores. Section Summary. In this section, we introduce evaluation metrics for FOLLOWIR, which include standard retrieval metrics when using instructions with queries and a novel pairwise evaluation metric called PMRR that measures rank-wise changes between queries. We evaluate a variety of IR models, some trained with instructions and some without, and observe that models without instructions generally have negative scores for PMRR, while models with instructions show mixed results, with some achieving slightly positive scores. Additionally, API models perform well in standard IR metrics but poorly in instruction following, indicating a gap in their performance in this aspect. Section: Instruct-tuned LLMs. In this section, we will discuss the performance of instruction-tuned language models, LLMs. We observed that all instruction-tuned LLMs showed positive results for following instructions, although their performance varied widely using standard information retrieval, IR, metrics. The best model in this category was FOLLOWIR-7B. We found that models with larger parameters, 3B+, or those explicitly trained to follow instructions, like FLON T5, without specific retrieval training data performed well in following instructions. This aligns with previous research in natural language processing showing that instruction following ability improves with scale and instruct tuning. We analyzed why many models struggle to follow instructions accurately even when they perform well on traditional IR metrics like NDCG and MAP. We conducted experiments by modifying components that could affect results, such as whether models are accustomed to instructions that are not suitable for keyword search or if they are familiar with longer instructions. We compared results when models were given the full instruction, a shorter instruction, or just keywords from the instruction. Our findings showed that models that struggled with longer instructions performed better with keywords and shorter instructions, while models adept at following instructions improved with additional information. We confirmed these results on various datasets beyond TREC collections, including SciFact, NF Corpus, and FIQA. Overall, we observed that models tend to use instructions for keyword matching and may struggle with longer instructions containing less relevant information. To enhance model performance in following instructions, we explored fine-tuning on a training set of longer instructions. We collected TREC narratives, instructions, from tasks not in FOLLOWIR, totaling 1836 query narrative pairs. We then generated relevant and non-relevant documents using GPT 3.5 Turbo 1106 and filtered them based on Mistral 7B Instruct v0.2's predictions. After balancing relevant and non-relevant samples, we obtained around 1,800 training instances from approximately 1,200 unique query instruction pairs. By fine-tuning Mistral 7B Instruct v0.2 on this data using the Llama Factory framework with LoRa, we trained our instruction following model, FOLLOWIR-7B. When evaluating this model on FOLLOWIR, we observed consistent improvements. Compared to Mistral 7B Instruct v0.2, our model showed enhancements in both standard IR metrics, 7.6% relative improvement, and instruction following, 13.3% relative improvement. This demonstrates that training IR models on longer instructions can enhance their ability to follow instructions effectively.